What's up, everybody? We're here on FreeCodeCamp.org. Let's do another daily code challenge. We get to the daily code challenges by going to our curriculum page once we're logged into FreeCodeCamp and try the coding challenge of the day. Go to the archive button, and we can step back to August 17th. That's the challenge we're doing today. The challenge on August 17th was targeted sum. Given an array of numbers, that's our array right here, and an integer target, that's our target right here, it's an integer, find two unique numbers in the array that add up to the target value. Return an array with the indices of those two numbers, or target not found as a string if no two numbers sum up to the target. We have one constraint. The returned array should have the indices in ascending order. Okay, so if we check out our test cases, we have this array of numbers and it looks like it's not always sorted. So that might matter later, but I don't think so. We have our array of numbers and we have our target value. Here we see that 2 plus 7 is 9. So the return result is 0 and 1 because that's 2 and 7 in our number array. Equally 2 and 4 add up to be 6. So it's index 1 and index 2. And this one, nothing adds up to be 14. So we have target not found. All right. Well, I could think of a really easy to reason about way of doing this, especially if you don't understand the key concept for a problem like this. The key concept is using the map object. With the map object, we could just do one loop through the array, keep track of what we've looked at in the array, and as soon as we find a matching value that adds up to our target, we can return those indexes. And that's probably the prime solution. But if you're not aware of map objects, you haven't used a map before, if you just kind of want to jump in and code this, you might think we need to do something where we loop through the array of integers. So I'll do the kind of more complicated, this one takes a bit more work typing wise to get done. It's a lot more code and it's going to run a lot slower. So we'll talk about that once I get this in here. So we're going to iterate over the array. And, we will need a variable to put our resulting two indexes into. I'll leave it null so we can do like a truthy falsy check. And yeah, I think you'll need an inner loop here. And so, disclaimer, don't do this. If you find yourself putting a loop inside of another loop, I can guarantee you there's probably a better way to go about it. When you do this, you are exponentially making your code run slower as the array gets larger. It's not a big deal when the array is, 4 items long, 5 items long, because at worst, you're going to loop over the array, what would be 16 or 25 times. That's not very many times, but as soon as the array is 100 items long, now your worst case scenario, if you don't find those two numbers until like the very end of the array, now you're looking at 10,000 iterations. You're going to loop 10,000 times to find this, and that's really unnecessary. So I wanted to get that disclaimer out of the way. So what we're doing is we are looking at the first item, and then we are iterating over the rest of the array. And we're actually looking at the first item twice. So we should check for that, I guess. We're not keeping this code. So there's probably a more clever way to devise these loops so that I and j can't be the same thing, but it's fine. We'll just continue. We'll skip that in this inner loop. And I guess we could also skip, since we need unique numbers, we can skip the case when the same number appears twice, if the same number appears twice, really. I didn't see that in our test cases. It's not going to be the case with this challenge, but I would consider that if I was writing this code for a production app, but I wouldn't do it this way if I was. So here we're checking to see if the value for the outer loop plus the value in the inner loop is equal to our target value, if they add up to be the target. If so, then we will set our result with a value, and it will be an array. The indexes in the array need to be in ascending order. So if the index I is less than the index j, then I will come before j. Otherwise, j will come before I. And then we'll break out of this loop. And then we need a way to break out of the outer loop too, if the result variable has a value. Because the result variable is going to be null until this happens. Once this happens, it's going to be truthy. We break out of this. Hey, it's truthy. We break out of the outer loop too. And then we would return the result, or if it's null still, we'll just return target not found. And I'm pretty sure that would do it. Doesn't require a lot of explanation. You can kind of, if you know what a for loop is, and you know what an if statement is, and you know how to access an array, this would make sense to you. We run it, and yeah, it passes. Cool. But the challenge is not complete. I don't consider this complete, because if my array is somehow 100, 1,000 items long, now I'm looking at iterating 100,000 times, 10,000 times, 100,000 times, 1,000,000 times, depending how big this array is. And we don't want that. We never want that. That's what makes slow, buggy apps that you have been angry with for years. So you don't want to contribute to that problem. Let's start over. Let's start over and consider a map. A map object is a key value store. That means it stores items based on a key, and that could be potato. The key of potato, we will give the value 42. And the key of fries, we'll give the value of 450, about 420. And now we can get the value at fries, and we can put it into, a variable, the fries value, and that's going to be 420. See that come out in the console? So we can use this map data structure, this map object, to iterate through the array once and just keep track of the numbers we've seen. So consider this. Same as before, we have a loop over the array. And each iteration we are setting the map to be the value at that index and the index itself. So thinking about this conceptually, in our test case examples down here, we would be setting the number 2, the value, so this would be 2, and this would be 0, because the value 2 is at index 0. The value 7 is at index 1. The value 11 is at index 2. Hope you get the point there. It's very important you understand that, because that's what this whole thing hinges on. We need a variable. I guess you could call this like the complementary value. It complements the value that we're iterating over. So I'll call it complement. And everybody likes compliments. I like compliments. You like compliments. Makes us feel nice, right? Now think about this. We have this target value. We're adding 2 numbers and seeing if this target value is the result. But we could think about it another way and think this target minus this value, is going to be something, right? In this case, in our first test case, we'll be looking at 9 minus 2. That results in 7. That's the matching number that we're looking for. So I could call it match too. Matching num, right? This is our matching number that we haven't seen yet, but we may want later. We may find it, and we may be able to clarify, like, yes, we have this matching number, and you know what? We saw the matching number for this number. So boom, what's the index? Let's go. We're done. And that's what we'll do here, because we can test to see if the map has something in it with the has method. So we'll check, does the map have matching num? Cool, then yeah, we've seen that matching number before. Let me go get it. So it will be, we could say index 0 or index 1, and we get that matching number out of the map. And then we have our second index, index 2, and that's the one we are on right now. That's the one we just realized, like, hey, this value at this index, when we find the difference with the target, we get this matching number, and we've proven, hey, we have that matching number somewhere in the map. We went and got that index, and now we have both of our indexes for the solution. So we can do what we did before, and this time we can just return it, right? Return index 1 is less than index 2. And if so, then index 1 comes first. Or the other way around, index 2 comes first. That's our result there. But we do have to consider then at the end of it, if we got through this loop and nothing returned, we didn't find a matching number, then we'll return, what was the string? Target not found. And that should do it, I think. I hope I described that correctly. This is a little harder to reason about because you have to know about maps, basically. You have to know that this is a tool in your tool belt that you can use in order to kind of keep track of things when you are doing some work, and then reference those things later and to see if you can end up with something that you are ultimately looking for in the array. So the map kind of serves as our inner loop. We think back to the first solution, we had an outer loop and an inner loop. We're iterating over I, going through all the numbers, and each time we do that, we iterate through all the numbers again to do our check. The map kind of serves as that inner loop because we just keep track of the things we've seen so far, because we don't need to look forward each time that we are going through the array. It's doing a lot of extra iterations, So that is the solution. I'm very surprised I didn't make a mistake when I was typing this. Yeah, I appreciate you watching. I'm actually looking at this. I could do this differently. We could sort them instead. Oh, I did the function body in the wrong spot. Here's our parameters and a minus b. So that should get us the same result. Yeah. So this is just a matter of putting that index 1 and index 2 in order. Again, thank you very much for watching. Like the video if you like this content, if it helped you. Subscribe to my channel. I'm going to keep working through these challenges. And feel free to comment below with any questions. It's kind of hard to debug your code over YouTube comments, but if you have a general question about using a map or that kind of thing, I'd be happy to answer, or someone else that watches this video in the future might be able to answer you too. So thanks again, and I will talk at you later.